I guess what happens is sometimes they have like 1,000 people in a meeting.
Mm-hmm.
And if they don't have that muted, there's no way to start the meeting because everybody starts talking at the same time. Kind of an interesting problem. But
Yeah.
so it looked like yesterday you could use some help in factoring.
Yeah.
That's what I'd like to work on today.
Okay.
Okay? You don't need to bring any problems to the table today. We'll just do factoring. That'll take up the whole half hour. Now, before we begin that, is this phone number I have, this is your number, 6131?
Yeah.
Okay. So in the future, is all I will do is text you the meeting ID number.
Okay.
Okay? And you have the software already, so you don't have to go back to that same website.
Right.
All right. So, and I forgot to record our other one, but I've got this set on record. So you
Okay.
get a copy of this. It might prove useful because I'm going to probably show you a way of factoring that nobody has showed you before.
Okay.
And it's going to work great whenever we have a first level quadratic. And by that I mean a quadratic with a 1 as its coefficient.
Mm.
Okay? Whenever the coefficient of the x squared term is greater than 1, it's going to be a much harder factoring problem.
Okay.
But the fact of the matter is that in Colorado, they give you all level 1. In other words, if you took a test on factoring, you'd probably get 90% if you could do all level 1.
Mm-hmm.
And the way I do level 1 factoring is absolutely the easiest way to memorize.
Okay.
All these sophisticated methods that they teach you, California method, diamond method, all of those are kind of with in mind covering higher level quadratics. But then it's all you get on your tests are first level quadratics. Trust me. If you take the SAT or the ACT, it's all you have to do is know how to factor first level quadratics.
Okay.
Okay. So let's start with the very first thing you want to pay attention to whenever you're factoring anything. What does that stand for?
Greatest common factor.
Okay. So if I had something like this, and I say, okay, solve this by factor. Now, the reason factoring is so important is because when you have a quadratic equals 0, you can't solve it.
Mm-hmm.
But if you can factor it, then you have two things multiplied together that are equal to 0. And you're able to say, well, either one of those has to be 0. You can't multiply two numbers together and get 0 unless one of them is 0.
Right.
That's an extremely important fact in math, is that whenever you multiply a series of things together and that's equal to 0, one of that series has to be 0. So first of all, let's talk about this quadratic that I've written. It's a typical quadratic that is going to require you to factor. And by that I mean it has an x squared term, it has an x term, and it has a number.
Mm-hmm.
So the only thing you might be able to do here is factor out a greatest common factor. Can we do that?
Yeah.
What
Well,
is it?
would you include the 2x squared?
Well, that's what we're going to teach you. Is
Okay.
when you factor out a greatest common factor, it has to divide into every single term.
Okay.
So what is the greatest, the largest common factor that will divide into all three of these terms?
2.
Yes. Okay. So the answer is 2 times something. Now, how do we get the something? What goes in the first spot?
X squared
Second spot?
minus 3x
Third spot.
minus 6.
Okay. Now notice what we've done. We've brought it down to a first degree quadratic. Because at this point, I can divide both sides by 2. So when I divide that by 2, it turns into a 1, so I don't need to write it. This stays at 0. So now if I'm trying to solve this, this is what I've got. A first level quadratic. So greatest common factor is very important because you might be able to take a second level quadratic and turn it into a first level quadratic. Now, had I written that as 5x, then I would not be able to divide every term by 2.
Right.
And I wouldn't be able to do it using greatest common factor. So, but the very first thing you should always look for is greatest common factor. Let me give you another problem. This time I'm going to think about it for a second. Now, whether or not I make that an equation by saying equals to 0, or I just leave it as an expression, doesn't really matter. If I tell you to factor that expression, how would you do it? Always start with greatest common factor. Can you take a greatest common factor out of that?
Yeah, 2.
Okay, what's left over?
X squared minus 7x plus 10.
Okay. Now, what you want to do is work with that. Now, in this case, we don't have an equation, so I can't cancel the 2. I've got to break it down. But I'm going to factor this quadratic that is in the parentheses. Now, what's the first step? I want you to learn this in steps because you will not believe how much easier factoring will become if you learn the proper steps. And every single quadratic you have, I want you to use these steps. What's step 1?
Like step 1 of the whole thing?
Yes, factoring is a process. I don't want you to try to do this in your head all in one step. Okay? So you want you to do it in the steps that I give you. The first step is what?
Greatest common factor.
We've already done that. So now we're dealing with x squared minus 7x plus 10. So how do we factor that?
Find two numbers that
first step, split up the x's.
Okay.
That's always that.
Oh, okay.
Okay, that's first step. Second step is to determine both signs, not just one, but both at the same time. So what do both, in other words, there's going to be a sign there, either plus or minus, and there's going to be a sign there, either plus or minus.
Right.
We can figure both of those out at this point. What are they?
Minus and minus.
Perfect. Minus and minus. Because the information, the only information we have is that plus sign right there.
Right.
That tells us that these signs have to be the same. They cannot be plus minus, because if they were plus minus, this would not be a plus 10.
Okay.
The only way you can get a plus constant is if the signs are the same. They don't have to both be plus. They can be minus minus or plus plus, and you look to the middle term. Middle term is minus, therefore they're minus minus.
Mm.
Third step. In other words, this is the first step. This is the second step. What's the third step? And I'd like you to verbalize it.
Find the two numbers that add up to 10 and, add up to -7 and then multiply to 10.
Okay. The way I would verbalize it is factors of 10, just 10, that add, because that's a plus sign, not subtract. If that was a subtraction sign, then they would have to subtract to this number. Mm-hmm. But because that's a plus, they have to add up to 7. What factors of 10 add up to 7? In other words, when I say verbalize it, I want you to do it as concisely as possible. Every time you factor a quadratic, the third step is looking for factors of this constant that either add or subtract, depending on whether that's a plus or a minus, to this number. Not -7, but 7.
Okay. So 5 and 2?
There's your answer.
Okay.
Okay?
Mm-hmm.
All right. So there's an example of where we applied greatest common factor first, because it turned it from a higher level quadratic into a first level quadratic.
Right. You
always want to do that if you can do it. Because first level quadratics are really rather easy to factor. They really are. I'm going to list the order that we should look at here. The second thing you want to look at is this. Dopes. You know what dopes stands for?
No.
Difference of perfect squares.
Okay.
So if I told you that a squared minus b squared always factors into a minus b times a plus b, that is a true statement. Mm. That is a perfect square. That is a perfect square. And that subtraction sign means we're talking about the difference of perfect squares.
Okay.
Okay. So if I told you this, factor that.
X minus 5, x plus 5.
Perfect. How about if I gave you this one? This is the one most people don't see. Still is difference of perfect squares. 1 is a perfect square number.
Okay, so then it's x minus 1, x plus 1.
So notice what difference of perfect squares is missing. The x term. Mm-hmm. It's got the x squared term and it's got the number. But it doesn't have an x term. And whenever you see that, then it's always worth looking at. It's going to be difference of perfect squares when you don't have an x term. I can just tell you that. Now, it may look like this. Let's make it an equation this time. First step. By first step, I mean, what's your first priority when you're looking to factor a quadratic?
Greatest common factor?
Yes. Start there always, no matter what it looks like. Start there.
Mm-hmm. So 2.
What's in the parentheses?
X squared minus 25.
Yeah, when you're doing these, every time you write something, check it.
Okay.
In other words, you don't want to wait till the end of the problem to go back and check your work.
Right.
You won't know where you made a mistake if you've made a mistake.
Mm.
If you check at every step, in other words, I'm checking right now, is 2 times x squared equal to 2x squared? Yes.
Yeah.
So you discover it instantly. What's the
Mm. Minus 25.
Okay. Now, what's the next line?
Dividing by 2 on each side.
Well, actually, you don't need to do that. You can leave the 2 there. And then it's x minus 5 times x plus 5.
Yeah.
And because I could have given you the problem without it being equal to 0, in which case you need to carry the 2 forward.
Mm.
When it's equal to 0, then you're right. I could divide both sides by 2, get rid of it, and then I have x minus 5 times x plus 5 equals 0. So, not a problem. Okay. So, those are always the first 2 things to look for: greatest common factor and difference of perfect squares.
Okay.
Now we'll get into the third subject. Quadratics. Normal looking quadratics. I'm just going to give you a bunch of them.
Mm.
That's a 13.
Okay.
Factor that. By my method, all 3 steps.
Okay. So it would be okay. So you would
First of all, we do check greatest common factor. There's none.
Right.
It's not difference of perfect squares.
Right.
So the next thing, we're going to factor it like a regular quadratic. By that I mean it has an x squared term, it has an x term, and it has a number. Whenever you see that, there's never a greatest common factor.
Mm.
Okay?
Okay.
Okay. So first step in factoring this first level quadratic.
Putting the x's in the
Separating the x's.
yeah.
You're going to find it isn't always x and x when you get to higher ones. In other words, if this was a 3x squared, then it would be 3x times x. But the one thing you know is that this term multiplied by this term gives you that first term.
Mm-hmm.
So you know that for sure. Second step.
Putting the signs, so a plus and a plus.
Third step, verbalize.
Taking the factors of 30 that add up to 13.
Okay, finding the factors of 30 that add up to 13. What are they?
10 and 3.
Okay, perfect. I don't even need to decide where the 10 goes and where the 3 goes. Okay?
Right.
So whenever that's a positive number, it's a 3-step process.
Mm-hmm.
I'm going to give you one more just to, whoops, hold on a second. This one I'm going to change it up a little bit. Notice what's different, that negative sign.
Mm.
When you see a negative sign in front of the constant, it's a 4-step process. As long as it's an elementary quadratic, a first level quadratic. First step?
Separating the x's.
Second step?
Putting the sign, so it would be a negative and then a plus.
Yeah, and because the coefficient of these two x's is the same, then it doesn't matter whether I write plus minus or minus plus.
Okay.
I'm always going to be able to do it either way. So I only have to write it once. Okay? Now, the third step's slightly different. Verbalize it.
Finding the factors of negative 10 that add up.
Nope, just 10.
to 10 that add up
Factors of 10 that do what?
that add to
Oh,
3.
this negative sign means they have to subtract to the.
Oh, okay. Yeah, so
Oh.
subtract.
Okay, so what are my two factors that subtract to the number 3?
5 and 2.
Okay, now that's 3 steps, but there's a 4th step because now it matters where we put the 5 and where we put the 2.
Mm-hmm.
And the rule is you put the highest number, 5, with the sign of the middle term. Simple as that.
Okay.
So the 5 goes with the negative sign. The 2 goes with the positive sign. And it matters. I cannot switch them up this time.
Okay.
Okay?
Yeah.
So these are 4-step factoring problems. Let's work with another one. First step.
Separate the x's.
Second step.
Do the signs.
Both of them. What are they?
Would it be a plus and a minus?
Third step.
Finding the factors of 12 that subtract to 1.
Perfect. What are factors of 12 that subtract to 1?
4 and 3.
Fourth step.
Putting the greatest one with the middle term, so x minus 4 and then x plus 3.
Very good. Very good. Let's try another few. Let me see if I can think of a hard one here. First up.
Separate the x's.
Yeah, you can say x and x.
Okay.
Second step.
Make the sign, so plus and minus.
And again, it doesn't matter if I write minus plus or plus minus.
Okay.
Third step.
Find the factors of 60 that subtract to 17.
Okay. Now that's a little bit more difficult.
Yeah.
First of all, how do we find all factors of 60? Start with the first one. Right?
So, yeah.
In other words, we're trying to factor 60. Some of these numbers can get pretty hard and it can get difficult to factor them. So what's another set of factors? What do I do starting with 60 and 1? How do I find the second set?
30 and 2.
Yeah, you cut 60 in half if you can and double the other number. That has to multiply to 60 also. Try it again.
And then 20 and 3.
Now, cut 30 in half.
Oh, so then 15.
In other words, always just cut it in half if you can.
Okay, so 15 and 4.
Okay. Now, I can't cut 15 in half anymore, but what can I do? I can cut it in thirds.
Right.
So 5
then
and what?
12.
Okay. Now, I can't cut 5 in anything.
Right.
But I can cut 12 in half.
Mm-hmm.
So 6 and 10. And now I can cut 6 in half. 3 and 20. Boom. I have finally found my two factors that subtract to 17.
Okay.
So what's my fourth step? In other words, these are my two factors. What's my fourth step?
So you put the largest with the middle.
Yeah, tell me specifically. Put the 20 where and put the 3 where?
Okay, so put the 3 with the x plus and then the 20 with the x minus.
There you go. Now, I'm done I'm finished the test, and I got some time, I can check this.
Mm-hmm.
You don't have to FOIL. Did they teach you FOIL? Are you familiar with the word FOIL?
Yeah.
Okay. You don't have to FOIL this thing to check the problem.
Mm.
I could just multiply it out. I'd have x squared minus 20x plus 3x minus 60. And then I would always combine those two terms. So you get x squared minus 17x minus 60. So I got the right answer, okay?
Mm-hmm.
So I did it right. I bet my life on it at this point.
Mm-hmm.
However, you don't have to go to all that trouble. Because of the way we factored, we know this term is correct, right?
Right.
It's not hard to separate the x's.
Mm-hmm.
And we know this term is correct.
Right.
That was part of the way we did it. We were looking for factors of 60.
Mm.
So the only question is that term correct? So when I'm checking these, the only thing I really need to check is the inside and the outside and add them together. That's what we did, was we took those two middle terms and added them together.
Mm.
The inside of FOIL gives you 3x. The outside of FOIL gives you minus 20x. You add them together, boom, you got the right answer.
Okay.
That's it. We don't need to do any more work than that. I call this my double smiley face, because all I'm doing is checking the inside term.
Right.
Now, this process also is extremely valuable whenever you're dealing with higher degree quadratics. It's part of the process. It's not a checking mechanism to see if you're right or not. It's part of figuring out the answer. Is this inside and outside, this double smiley face down here.
Mm.
Don't really have time to go over it today, and I don't want to anyway. I feel like what we did today was we really covered first level quadratics really well. I really believe you learned it. You'd be able to do any first level quadratic that's factorable. Now, before I let you go, let's look at this one again. That factored into x minus 5 times x minus 2. If I change this number to a 9. In other words, that's a quadratic also. Okay.
Right.
Now, if I try to factor it, separate the x's, determine the signs, both negative. Now, are there any factors of 9 that add to the number 7?
No.
Okay. What that tells you is that you cannot factor that in the normal way. And when you run out of ways to factor it, you only have one method. That's the quadratic formula.
Right.
Quadratic formula will solve all quadratics. Doesn't matter whether they're factorable or not. It will solve this one right here.
Mm.
We're not going to do it this way. We're going to use the quadratic formula, which is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. You want to memorize that. That's probably the hardest thing that they ask high school math students to memorize, is the quadratic formula. In fact, most schools teach you a song, much like the ABCs. I wouldn't know my ABCs to this day if they hadn't taught it to me with a song.
Right.
In fact, if you ask me whether I comes before J, I have to go A, B, C, D, E, F, G. Okay? Yeah. Same thing with this quadratic formula. I don't care how you learn it, memorize it.
Okay.
Okay? You're going to have to know it when you take the SAT. You're going to have to know it when you take the ACT. And you're certainly going to have to know it for all your math classes. And it's one thing they don't give you frequently. They're going to expect you to memorize it.
Okay.
Okay? And in terms of what all this means, A is that coefficient, B is that coefficient, and C is that coefficient.
Right.
So in this case, A would be 1, B would be -7, C would be +9. That will give you the answer to that quadratic, what the solutions would be. If that was all equal to 0, you would figure out what values of x make that true by using the quadratic formula.
Okay.
All right. River, I will let you go, and I have your email. I will send you a link when this thing gets processed and a link for reviewing it. And this might be one you want to review.
Yeah.
You want to know every single thing we have said today. This is, I can't think of a more critical 30 minutes of learning for algebra than this.
Okay.
Okay?
Okay.
River, have a good day. I'll talk to you next time.
Okay, thank you.